Hello girls, today we are going to see about video compression. Basically, video compression technology is about reducing and removing redundant video data so that the digital video file can be effectively sent over a network or stored on computer disks. Uncompressed video, let's try and understand how much space it will need. Uncompressed video that we record from a video camera, that is for example movies, occupies huge amount of data. For example, a simple video clip recorded with a resolution of 720 by 576 megapixel with the refresh rate of 25 frames per second and 8-bit color depth takes around, with the calculation you can see, 1.66 MB per second for luminance and chrominance. And for HD TV, that is high definition television, you can see with the calculation that it needs 1.99 GB per second. Note that YUV color space, each pixel has one brightness, that is luminance value, and two color, that is chrominance values. That is why arises a need for compression. Digital video sequence that are most demanding form of data in various fields pass through computer network or portable storage devices like CDs, pen drives, etc. Uncompressed video impose of following. Firstly, obviously, it will need large bandwidth for the transmission requirements, and then it will demand for a huge amount of storage capacity for a small medium. Then once we have understood that compression is pretty much important, along with it standardization for the compression is also important. There are different compression technologies, both proprietary and industry standards are available. Most network video vendors today use standard compression techniques. A standard is important in ensuring compatibility and interoperability. They are particularly relevant to video compression since video may be used for different purposes, and in some video surveillance applications needs to be viewable many years from the recording date. As you can see, during the lockdown, we are once again seeing Ramayana and Mahabharata on the national television. With how? With the help of previously recorded video signals. So we need to have basic standard video compression algorithms which will even work after many years of recording. And then by deploying these standards, end users are able to pick and choose from different vendors rather than be tied to one supplier when designing a video surveillance system. Hence, there comes codec in the picture. What is codec? Basically, it is video coder and decoder together. The process of compression involves applying an algorithm to a source video to create a compressed file that is ready for transmission or storage, and to play the compressed file, an inverse algorithm is applied to produce a video that shows virtually the same content as the original source video. This is how, in simple format, working of codec works. Firstly, you start in encoding where you have your original digital data. You apply a compression algorithm onto it. You will get a compressed data. You will put that onto a storage. From the storage, you will retrieve compressed data at the decoding end. Then you will apply decompression algorithm to it, and then what you will get back is a kind of original data. Obviously, it will be kind of a lossy compression. So a pair of algorithms that works together is called as video codec. One algorithm for encoding, another for decoding. Video codecs of different standards are normally not compatible with each other. That is, a video content that is compressed using one standard cannot be decompressed with the different standard. For instance, if you are decoding using MPEG 4, which will not work for a encoded part of H.264. This is simply because one algorithm cannot correctly decode output from another algorithm, but it is impossible to implement many different algorithms in the same software or hardware, which would then enable multiple formats to coexist. How video compression works. Video compression algorithms such as MPEG-4 and H.264 use interframe prediction to reduce video data between series of frames. This involves techniques such as difference coding, where one frame is compared with the reference frame and only pixels that have changed with respect to the reference frame are coded. In this way, number of pixel values that is coded and sent is reduced. When such encoded sequence is displayed, image appears as in the original video sequence. For example, if you have one frame where a house is there and a man is trying to run to reach to the house, then basically this house is going to remain stationary in n number of frames. Do you agree? So what we are going to do is we are going to transmit this house pixels only once, and then down the remaining frames we will not transmit frames for or pixels for house. We will transmit only for the pixels for running man. How to manage this? This could be managed with the help of creating different frames and then giving different types to these frames. These frames could be classified into I frame, P frame and B frame. So let's see each one in detail. An I frame or an intra frame is a self-contained frame that can be independently decoded without any reference to other images. That is, basically the first image in the video sequence is always an I frame. I frames are needed as starting point for new viewer or synchronization point if the transmitted bit stream is damaged. Iframes can be used to implement fast forward, rewind and other random access functions. An encoder will automatically insert iframes at regular intervals or on demand if new clients are expecting to join in viewing a system. Drawback of iframes is that they consume much more bits, but on the other hand, they do not generate many artifacts which are caused by missing data. A P frame basically stands for predictive interframe, which makes reference to the parts of earlier I frame or earlier P frames which are transmitted through the coder. P frames usually require fewer bits than I frames, but the drawback is they are very sensitive to transmission errors, and because of its dependency on earlier P or I frame, it is difficult to come out of transmission errors. A B frame is basically a bipredictive interframe and is a frame that makes reference to both an earlier reference frame and a future frame. Using B frames increases latency. So when a video recorder restores a video by decoding the bit stream frame by frame, decoding must always start with an I frame. P frames and B frames is used must be decoded together with the reference of previous frames. Advantages: it occupies less disk space, reading and writing is faster, file transferring is faster, and the order of bytes is basically independent. Disadvantage: compilation needs to be done again for compression. Errors may occur while transmitting data, and the byte or pixel relationship is unknown, and it has to decompress previous data to understand what has been transmitted or received in the previous frames. Thank you.